Okay, great. So we are now on to the third function, login. And this one, once again, takes in a username, a string type of data, produces this time a Boolean. And that Boolean indicates whether the username can be logged in. So they function get a pin from the user. It's going to use the function we defined and compare that to the user's pin. Um, and to do so, we're going to do several different steps that we'll spell out. It does say this function takes user input, so we're not going to write our own test cases this time. This is just like part one. So BlockPy will tell us if we ended up getting it right. It will tell us if we pass the instructor unit tests. So if that's all we need, then we can go down and start by defining our login function. So we define the name, login. This one takes a parameter, so username string, and it produces a bool, right? A Boolean function. We can document our function, checks to see, gets the user's pin and checks that it is correct for that username. So this one args takes in a username, which is a string, the user's username, and returns a Boolean indicating whether the user's pin is correct. Okay, so that's our documentation and our function header. So we don't have to write any unit tests. They do tell us pretty much exactly how to write this function, though. So that's the next step. We go up and we can refer to this set of 3 steps that they give us. First things first, we take user input, requesting their pin, and we convert that to an integer. So let's go down and get their pin. So the given, let me call the what is your pin as a prompt, and I have them store that in a variable. We're going to need to refer back to it in just a little bit. We check to see, we go in, we're going to then compare that. We're going to need to call the getPin function, passing in the username parameter. So if you look at our diagram from before, this is what this is saying. When you call login, it calls getPin. And the string value that was passed into login, that gets passed right along to getPin. And getPin will return a integer value for us. So we go down here and we write our next line of code. We call getPin and we pass in username, right? So this function gets called. We're passing in the parameter username. It's totally fine. We're not passing in a string literal value, right? We're not passing in AC Bart or Babbage. We can't do that because we don't know what username is being passed in. We have to use the variable that was passed in instead. We want to take that value and we're going to need to check some things with it. So we'll store it in a variable. So now we've stored the given pin that the user just typed in and the actual pin that we got based on their username. So let's go back up to the instructions and we see that the login function's last step. We return false if the getPin function returned -1 or if the user inputted pin was not equal to the result of getPin. So we were trying to compare the 2 pins, the actual and the given, and making sure that they match. Otherwise, the user put in something else. We also want to make sure they didn't just type in -1. There are several ways to write this, several clever ways of doing it. You don't actually need an if statement. You can do this with a clever use of ors or ands, but we're going to use it just to be a little bit more explicit. So first things first, we'll check to see if the actual pin was equal to -1. If actual pin was -1, then we return false, right? The user typed in, it doesn't matter what the user typed in, the getPin function returned -1, which means that the username that was given to login, they weren't in the system. So that's whatever, it doesn't matter what the user typed in, they're garbage, they get returned false. Alternatively, otherwise, we check to see if the given pin is equal to the actual pin. And if it is, we return true, otherwise we return false. We could have made this a elif and returned true or returned false, but that's unnecessary, right? Like if we're just returning true or false, we might as well just return the value directly. We're allowed to do that in BlockPy, in Python. So let's see what happens if we try running this, see if we got it correct. So we run it. Unfortunately, though, we're not correct. Student code failed the instructor test. They ran the function login, passed in the string Ada, and then they entered as input, because like the box appeared, they entered as input 1, 2, 3, 4, and the result was false instead of true. So they called the function Ada, the function login, passing in the Ada user, and they typed in the right pin for Ada, but it still returned false. That's pretty weird. And we don't have any test cases of our own that we can run. So how do we figure this out? How do we know what went wrong? We're going to go down here and we're going to call our login function ourselves, modeling exactly what they did. So we're going to call login passing in Ada, and when the box appears, we'll type in 1, 2, 3, 4. But we're going to make a small addition to our code. We're going to add in a print statement. We'll put it right here near the middle of the program. This is the wolf fence debugging technique. We divide the program into 2 halves, try and narrow down where the issue is, and we'll print out some information. We're going to print out the given pin. We're going to print out the actual pin, and we're also going to print out the result of given pin versus actual pin. Now, it's really useful that we define these variables before, given pin and actual pin, because we get to reuse them. It's also really important that we did this, right? Some people will just start calling the getPin function multiple times, and if you do that, that's a problem, because every time you call, not the getPin function, the input function, I apologize. Every time you call the input function, if you try to use that instead of the given pin, then it's going to reprompt the user every single time. And that's a giant pain, right? Like the user won't like that. So we want to only call the input functions once, store the result in a variable, and then we can use that variable any number of times. It's just the value. It doesn't remember how it got the value, doesn't remember that there's user input involved. It just knows it has the value. So I'm printing out some debug information. I'm calling the function. Let's go and run our code. It's running it and asking me what is the pin for Ada. So we type in 1, 2, 3, 4 like the computer did. And it prints out almost what we'd expect, right? It printed out 1, 2, 3, 4, 1, 2, 3, 4, false. The given pin, it printed out as 1, 2, 3, 4, and the actual pin is 1, 2, 3, 4, but it thinks that those two things are not equal. And that must feel like crazy pills, right? Like 1, 2, 3, 4 is definitely equal to 1, 2, 3, 4. Well, if they look equal, the thing to remember is that they could be different types, right? This could be string data, and this could be an integer, an actual int type of thing, and that would mean that they cannot be equal, right? Because two things of different types cannot be equal, except for integers and floats. That's the exception. But an integer and a string certainly can never be equal because they're different types. If we go and look at the instructions closely, we'll see that they wanted us to take user input requesting the pin and then convert it to an int. If we go look down at what I've written here, on line 51, I do get the user's pin. I ask for it, but I don't convert it to an integer. Now, you may remember that the way we convert to an integer is with the built-in int function. So I just pass the result of input into the int function, and now given pin will work correctly. Let's see if it's correct when I type in 1, 2, 3, 4. It is now indeed printing out that they are equal. They are equivalently true things. BlockPy does not mind that I have left my print statement in there, but let's get rid of it because it's clogging things up. I can also get rid of this little personal test case I had to make sure to debug with. We always get rid of unnecessary print statements, unnecessary debugging code. If we don't need it, we don't have it. If we go back to the feedback, we saw that we were passing BlockPy's tests. And with that, we finished the first 3 functions. There are only 5 more functions that you have to write. I'm going to let you tackle them on your own. But remember, you're not really alone here. Your cohort is all working on this too. And I strongly urge you to schedule a time to sign on together and work together on this project. Like it was a lab. This one, I definitely want you to think of it more like a lab than a project. We also have the staff office hours and the Teams, the Microsoft Teams, lets you ask questions. This is a tougher assignment, but it's going to really help you practice a ton of essential skills relating to functions. If you can do this project, you are ready for all the more interesting stuff we're going to do this semester. If you're struggling with it, then it's really important. This is a great learning opportunity for you to get a handle on functions. So from here, I'm just going to say good luck and make sure you're learning as much as you can.